Hello everyone, I welcome you all to Dr. D.Y. Patil Vidyapit Center for Online Learning, and we are learning statistics and quantitative techniques. So in previous session we have already covered the units 9 and 10, but in between two units remained, and we are starting with the unit 7, and we try to cover unit 7 and 8 in today's session. Okay, so today's session is about, first unit 7 is about the probability and probability distribution. So I will brief you about what is the probability, and we'll see just one distribution. Because of time constraints, it is not possible for me to explain you all the distributions, but I try to cover at least one distribution in this session. And the next session, next unit is a linear programming problem. So that is unit 8. So after finishing this, I'm starting with the unit 8. Okay, so let's start with this unit, probability and probability distribution. So what is basically the probability? The probability is how frequently we expect different outcomes to occur if we repeat the experiment again and again. So if we have certain we are doing some experiment and we repeat the experiment again and again, so what is the chance that our expected outcome will come? That we are finding in probability. Okay, so what is basically the experiment? So experiment is something capable of replication under stable conditions again and again. So the experiment we call, which you can repeat again and again under stable conditions. Okay, so if you are tossing a coin, then it is your experiment. Okay, so you are tossing a coin, you are tossing it, let's say 5 times, 10 times, so you're repeating it again and again and again and again, and you are finding a chance that you are picking, let's say you are tossing a coin and you get the head. So what is the chance of getting head when you toss a coin? That you are finding here. So what is a sample space? The set of all possible outcomes of an experiment is your sample space. Okay, so when you toss a coin, what are the all possible outcomes you have? Can you tell me what are the outcomes when you toss a coin? When we toss a coin, we have either head or tail, right? So our sample spaces just head and tail. Just 1 second. So when we toss a coin, our outcomes, all possible outcomes, either we get head or tail. So our sample space become head or tail. So if you toss up 2 coins at a time, okay, if you try to toss 2 coins at a time, so when you are tossing a single coin, tossing a coin. So when you toss a coin, your sample space, we denote it by capital S, and it is head and tail. So when you toss 2 coins, at a time, so you're tossing 2 coins at a time. Okay, so your sample space becomes HH, TT, TH, or HT. Any possible outcome is there. Okay, so this is your sample space. When you are, let's say your experiment is you're selecting a card from well shuffle pack of the cards. Okay, so in card we have 52 cards, so all 52 cards become your sample space here. So what is the event? Event is a subset of the outcomes of an experiment. So whenever you are tossing a coin, let's say if you are here tossing a coin twice, or 2 coins we are tossing at a time here actually. So HH, HT, TH, TT. Okay, so an event could be that you got at least one head on. So one head on means at least one head, means it is possible that 2 heads are there or one head. So the event have outcomes HH, HT, TH, right here. So any subset of your sample space is your event actually. Okay. So we have the definition of the probability that if A is the event and there are n number of elements in A, so we denote it by n of A is number of elements in A. Okay. So, and S is your sample space and S is sample space. So n of S is number of elements in sample space. Then your probability of A is n of A divided by n of S. This is a simple definition of the probability we all know. So, okay. So we are learning this probability. Probability of A is n of A upon n of S, where your probability of A always lies in between 0 to 1. Okay. And if you try to find out the probability of the sample space, okay, so what is the definition now? Probability of A is n of A upon n of S. So when I try to find out the probability for the sample space, P of S is n of S divided by n of S, right? So it comes 1. So your probability of S is always 1. Okay. The same thing is explained for by taking some another event probability of event E. Instead of A, here they have written event E. Okay. So then we see some concepts in the probability theory. So what is the complement? The complement of A is everything in the sample space S not in A. So S, the complement of A. So if S is your sample space, A is your event, and you're finding out A complement means everything in sample space which is not in A is the complement of A. So by graphically, the blue portion is the A complement. So we have the theorem. So A complement is, we denote it by like probability of A complement we write, or probability of A dash sometimes write. It means A complement. Okay. So that is 1 minus probability of A. We know the probability of A. Probability of A is n of A upon n of S. If A is the event that randomly selected student is male, and the probability of A, now what is given here, probability of A is 0.6, right? So what is the probability of A complement? You can use the theorem. Probability of A plus probability of A complement is always 1, because the probability of sample space is 1, right? And what is your probability of what is your A complement? Everything in the sample space which is not in A. So probability of A plus probability of A complement is always 1, or you can write like this, simplicity, for simplicity or understanding. So your probability of, by this theorem, probability of A complement is 1 minus probability of A. So you can directly write down probability of A complement is 1 minus 0.6, that is 0.4. So what is the probability of A complement? A complement is even that randomly selected student is female and its probability is 0.4. Now the next is the union. So we denote it by the sign like this, U. It's for union. Okay. So A and B. So this sign we use when we have and in between, A and B. Okay. And for union. So union of A and B is everything in the sample space that is in either A or B. Sorry. A or B. Union means A or B. Your element can be in A or can be in B. So this union is related to the word or. Okay, so the union of A and B is the whole white area. Okay, and this is about the intersection. So intersection is the common point. So this is A and B. This is related to and. So your intersection is related to the and union is related to the or. The intersection of A and B denoted by A intersection B. So we denote it by like this. Is everything in a sample space that is in both A and B. A intersection B means common portion in between A and B. So this is an example by which we can see the different concepts, whatever we have learned currently. So the family is planning to have 2 children. Suppose the boy B and the girl G are equally likely. So the family is there who is planning to have 2 children, and the chance of the birth of the boy and girl is same, equally likely, same chance. What is the sample space S? So it is possible that they have the first boy and second boy, first girl and second girl, first boy, second girl, and first girl, second boy. All 4 possibilities are there. So this is a sample space S. So if E is the event that both the children are the same sex, so both are boys or both are girls, so your event E becomes BB or GG. So your S is BB, GG, BG or GB, right? Now your event E is both the children have the same sex, so they both are boys or both are the girls. Okay, so you can see this is a subset of the sample space BB, GG, BG, GB. Only 2 elements from sample space are here. So this is a subset of sample space, and this is our event for which we are finding out the probability. So N of E is number of elements in E. 2 elements we have. So the probability of E is N of E divided by N of S. Number of elements in E divided by number of elements in sample space, that is half. So what is the complement of E? So we are using the same example, okay? What is the complement of E and what is its probability? So E complement is everything in sample space which is not in E. So our event E is BB or GG, right? Sample space is GG, BB, BG, and GB, right? So everything in sample space which is not in E is these 2 elements. So these are the elements in our E complement, okay? So E complement, you can directly find out the probability. Like probability of E complement is N of E complement divided by N of S. And that is 2 by 4, that is half. Or the another way is, you know the probability of E. Probability of E we have already calculated, that is 0.5. So you can directly find out the probability of E complement is 1 minus probability of E, and that is 1 minus 0.5 is 0.5. If F is the event that at least one of the children is girl, what does F look like and what is its probability? So what is F? F is the event that one of the children is girl. So one girl is necessary in the event. So if you see the event F becomes B, G, G, B and GG. At least one girl should be there. We are not writing here BB because in BB both are boys. Okay. So the probability of F is N of F divided by N of S, that is 3 by 4, and that is 75. Okay. So now our E is the event that both the children have the same sex. Probability of E is 0.5. F is the event that either at least one child is a girl child, so the probability of F is 0.75. What is E intersection F? What is E intersection F? Now intersection means, intersection is related to the word and. So what is common in between E and F? E and F. What is common in between E and F? E is the event that BBGG and F is the event that BG, GB and GG. So GG is common here, right? So in E intersection F, we have only one event, that is GG. And N of E and in E intersection F is 1. So the probability of E intersection F is N of E intersection F divided by N of S. That is 1/4, that is 0.25. So now we know the event E and its probability, event F and its probability. What is E union F? Now union is related to OR. What is common in between E or F? So you are combining it. What is the elements in between E or F? So your E or F you are finding now. E or F. Intersection means and. So the element must be present in E and F. Now we are doing union. So union means the element is present either in E or F or in both. Anything is possible. So let's write BB, GG, BG, GB. I'm not writing GG again because I have already written it here. Okay, so E union F is this. So N of E union F is 4. So probability of E union F is N of E union F divided by N of S. So that is 4/4 and that is 1. Okay, so this is the example, and if you add the separate probabilities of E and F, so what is the probability of E here? 0.5. And what is the probability of F? 0.75. So if you add this, the total is greater than 1. The probability total cannot be greater than 1. Okay, so it does not work. So why this is happening? Because something is common in between them and we are counting it twice. So you have to subtract that probability. Okay, so we have the theorem, probability of E union F is equal to probability of E plus probability of F minus E intersection F. So probability of E plus probability of F minus the common in between E and F. You're subtracting it. And when there is no overlap, okay, so if two events are separate from each other, that time E union F is probability of E plus probability of F. So let's take one more example for understanding this. So let's queen cards from the pack of the cards. Okay, so I'm selecting queen cards from the pack of the well shuffled pack of the cards. So probability of selecting a queen card is 4/54, 52, right? I'm selecting the king cards from the let's say two red king card. B is probability that red king card is there, and A is the probability that queen cards. So 2/52. Is anything common in between them? No. So when you find out probability of A union B, you can directly write probability of A plus probability of B minus probability of A intersection B. But there is nothing common in between them. So this becomes 0. So your probability of A union B becomes probability of A plus probability of B, and that is 4 by 52 plus 2 by 52, that is 6 by 52. Okay. So this is just the introduction to the unit probability. Now we'll see some of the part of probability distributions. Okay. So probability distributions, we are learning actually um, what we are learning here is we have the probability distribution functions. So we are learning the functions here. So what is the function? Basically, function is something to which if you give the input, it will give you some output, some kind of output. Okay. So if this is a function f of x, so you have to give some kind of input to it. So this is the function of x, so you are giving the value of x, some other parameters, maybe it has. If you provide this information, it will give you some kind of output. Okay, so function is something to which if you give input, it will give you kind of output. So like mod function, this is a function. So if you say -2, it will give you 2. If you put 3 in the mod function, it will give you 3. Okay, so like you can have a number of functions. So here we are learning probability distribution functions. Okay, so here for each of the probability distribution, we will see that there are different functions. So if you are learning normal distribution, then you are learning probability distribution function for the normal distribution. That is 1 upon sigma root 2 pi e raised to long function e raised to minus x minus mu square upon 2 sigma square. But what you are learning here is what are the different variables of inputs you have to give to the function and what will be the output. Okay, so whenever you are learning about the probability distribution functions, these are the functions which gives you the output as the probability. Okay, so every time you are giving the inputs, your answer is coming in probability because you are learning probability distribution functions. Okay, so there are different kind of distribution functions, like for discrete type of a data, you have probability mass function. For continuous type of a data, you have probability density function. Okay, so discrete kind of a data means the data which takes a complete number 0, 1, 2, 3, 4, and so on. And continuous type of a data which takes all possible values. Okay, so under discrete distribution, we can have different distributions like binomial distribution, Poisson distribution, and so many distributions are there. Like an example of the continuous distribution is normal distribution, chi-square distribution, and so many. So in today's session, we are learning about just one distribution, that is a binomial distribution. Okay. So probability distribution, discrete distribution, a random variable can take only limited values. Continuous distribution, it takes all possible values. So discrete probability distribution example. So for different values of x, okay, values are changing. X is taking value 0, 1, 2, 3. So you're finding out probability. Okay. So tossing 3 coins at a time. So your sample space will be HHT, HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. Let X represents number of heads. Now, what is your random variable for which you're finding out the distribution? X is number of heads. So how many observations are there with the 0 head? Only one observation. Okay. So how many total observations in the sample space? N of S is 8, right? So let's say how many observations have the value? How many observations in this sample space are there with a 0 head. So we have only one element here, right? So the probability that x takes value 0 is 1 by 8 because there are total 8 number of observations in the sample space. How many observations have one head? So this observation has one head, this observation has one head, and this observation has one head. So 3 by 8 is the probability. How many observations have two heads? 3 observations. Okay, this, and this. 3 observations are with 2 heads. So x is taking value 2. The probability is 3 by 8. How many observations are with 3 heads? Only 1. So the probability is 1 by 8. Okay. So now we come to the binomial distribution. So there are certain situations where when we use the different distributions. Okay, so particularly binomial distribution when we use when our experiments gives us the value as a answer to yes no type question. Okay, so when your distribution is giving the value uh, in to the yes no type questions, like something is present or absent. If you toss a coin, either you get head or tail. Okay, so if you're selecting a pink ball from a box, you will pick the pink ball or not. Yes no type questions, answers are there. That time we use the binomial distribution. Okay, probability theory and statistics, the binomial distribution comes with the parameter n and p and is a discrete probability distribution. So we use a binomial distribution when our data is like we are counting. We can count. You are counting something. That time you are using the binomial distribution, discrete type of a data. The data taking complete numbers. Okay. So the binomial distribution with parameter NP is a discrete probability distribution of the number of successes in a sequence of n independent experiments. So each asking a yes/no question. So you are repeating the experiment again and again, and you are checking whether your expected outcome is coming or not. So you either get your outcome yes or no, yes or no. You are repeating the experiment again and again. So if you are interested in getting ahead and you are tossing a coin, you repeat the experiment again and again, and you are just noting down whether a head is coming or not coming, coming or not coming. Okay, so such type of experiments we use the binomial distribution. So we call the success probability as P. So when we say yes, the probability is P. When our outcome does not appear, we say the failure and the probability is Q. And Q is 1 minus P. Okay. So what are the parameters here written N and P? So what they are? So if you see the probability mass function for the normal distribution. Now, remember that for discrete distributions, we have the probability mass function. Okay. And for the continuous distributions, we have the probability density function. So here the binomial distribution is discrete distribution. That's why we have probability mass function here. Probability that x is equal to r is NCR P raised to R Q raised to N minus R. This is the function for binomial distribution. So if you see the function is NCR. So for finding out the value, you need to know the value of N. You're finding the probability at R, right? So R is continuously changing. So you have to give the output input as R at the different R. So you need to know N, you need to know R, and this is C is the combination function we have in mathematics. So this is NCR P raised to R. So you need to know the value of the P, value of the N, value of the R, right? So again, R is repeating, so I'm not circling it. Q raised to N minus R. So once you know these three values, value for N, value for P, and value for R, you can find out this probability. Okay. That's why the value of R is always changing. So the remaining two are the parameters for these distributions. Parameters means those values which you need to know before calculating the probability of that distribution. If you don't know the values of the parameters, you cannot find out or do the calculations for the probability, because these are mandatory in the probability mass function or probability density function, whatever the function it is. Okay, so parameters for the distribution you need to know before doing the calculations. Okay, so for the normal distribution you need to know the values for n and p. N means number of times you are repeating your experiment, and p is the probability of success. Okay, once you know the p, you can easily find out the q. Q is 1 minus p, right? So you need to know the, once you know the p, you can calculate the q. So n is number of times you are repeating the experiment. R is the value at which you are finding out the probability. So p is the probability of success and q is the probability of failure. So the same equation has been written here. So here we are finding out the value for x. X is basically the random variable. It can take any value. Okay. So in the previous function, I have written small x as r. Here I have written x, but don't get confused. It is just the value you're giving, means you are finding the probability that x takes value 2. Okay. So you're finding the value at this particular probability. Sorry, for at that particular number. So let's see the example so that it will become more clear to you. A fair coin is tossed 12 times. So we are repeating the experiment 12 times. So our n is 12, right? N is 12. What is the probability of getting exactly 7 heads? So we are tossing a fair coin. The probability for the fair coin is, probability of getting head is 0.5, and probability of getting tail is also 0.5, right? So because the coin is fair coin. So when we say the coin is fair coin means a chance of getting head or tail is equal. Generally, when your one of the side of the coin is heavy, more heavy, that time that side comes down. So for the fair coin, the chance is equal chance for getting head or tail when you toss a coin. Okay, so the probability is 0.5. So q is also 0.5, that is 1 minus 5, right? 1 minus p is q. So q is also 0.5. So what you are finding? You are finding at x is equal to 7. So you are finding out that you are tossing the coin 12 times and the probability of getting exactly 7 heads in the 12 toss. First time you try to understand what is this. You're tossing a coin and repeating the experiment 12 times, and every time you are noting that whether you are getting the head or not. Okay, so how many what is the chance that exactly 7 times you get the head when you toss the coin 12 times? Okay, so our probability mass function is probability that x takes value 7, or let me write for first x is ncx p raised to x q raised to n minus x. So x is taking value 7. So probability that your random variable takes value 7 is n is equal to 12 c7, p is 0.5 raised to 7, and q is 0.5 raised to 12 minus 7, that is 5. So once you solve this, your answer is, I've already done the calculations and the answer is written here 0.193. So the probability of getting exactly 7 heads is 0.193. Okay. So the probability that person can achieve the target is 3/4. The count of tries is 5. What is the probability that he will attain the target at third trial? So what is given and what is asked? Now, how to understand this is the question for the binomial distribution. So try to read the problem again. The probability that the person can achieve the target. So probability of the success is given. The number of experiments is given. Okay. What is the probability that he will attain the target at third trial? So you are asked to find out the value for x is equal to 3. Probability that x is equal to 3 is what? So once you know these two things, your Q is 1 minus P. So you can do the calculations 1 minus 3 by 4, that is 1 by 4. Okay. So you are putting the values in the formula, that is NCX, P raised to X, Q raised to N minus X. So what is N? N is 5, 5C, 3. P is 3 by 4 raised to 3. Q is 1 by 4 raised to 2. So you can do the calculations and find out the answer. The answer is 0.263. For calculations of the NCR, you can do it directly using the calculators, or you can use the formula of the combination, that is n factorial divided by r factorial n minus r factorial. You can use the formula and you do the calculations, or directly you can do the calculations using the calculator. So this is the problem, that a box of candies has many different colors in it. There is a 50% chance of getting a pink candy. So probability of success is 0.15. What is the probability that exactly 4 candies in a box are pink out of 10? So you're repeating the experiment 10 times, means you're picking the candy from the box and you're checking it and keeping it back. Okay, so every time you are noting the color, whether it is pink or not. If the pink is there, yes. Pink is not, no. So what is the chance? How many times you are getting the success? The chance of getting success is 0.15. So the Q is 0.85, that is 1 minus P. Then what is the N? How many times you are repeating the experiment? 10 times. And what is asked? Probability that X is equal to 4. So NC, probability that X takes value X is equal to NCX P raised to X Q raised to N minus X, and that is N is 10C4, P is 0.15 raised to 4, and Q is 0.85 raised to 10 minus 4 is 6. So you can do the calculations and tell me the answer. The answer is 0.03843. So if you are confused in finding out NC4, you can directly search the value for this. This is the mathematical function, combination function. Combination we use for the selection, okay, and permutation. If you remember, we have the permutation combination. The permutation we use for the arrangement of the objects, and combination we use for the selection of the objects. So NCR. So here we are done with this unit, unit 7. So my plan is I want to start with the unit 8 now, that is linear programming problem. So if you have any query in this unit, you can ask me now.
Hello.
Yes.
How did you find the 0.85?
1 second.
How you found the 0.85?
0.85 is Q, right? Probability of failure. So 1 minus probability of the success is probability of failure. So the probability of success is 0.15, right? 0.15. So Q is 1 minus P, that is 1 minus 0.15, and that is 0.85.
Okay, thank you.
So I've shared a link with you. Kindly go to the link and share your feedback. I'm starting with the next unit, that is unit number 8. This unit is So we are starting with the unit 8, and unit 8 is linear programming problem. So in this unit, we will learn about how to solve the linear programming problem graphically. So actually, I missed this unit in between, and we have seen the next 2 units based on the optimization, that is the assignment and transportation, right? So unit 9 and 10 are also based on the optimization theory, and this is also based on the optimization theory. So we have already covered unit 9 and 10. So the remaining part is the unit 8 linear programming problem. So what we are learning in this unit is we are trying to find out, we are learning the linear programming for just 2 variables. We have the 2 variables, and we have the objective function which we want to maximize or minimize. So if the objective function is giving you the value for the, if the objective, can you see the PPT?
Yes, I can
Yes.
see it.
The objective function is the function which you have to maximize or minimize, and the objective functions are means basically the functions formed by for the maximization of the profit or minimization of the cost. Like if you are dealing with the things like a profit, so you always try to maximize it, right? So if the information is given in the problem related to the cost, so you will try to minimize the cost. So the optimum value means either maximum value or minimum value you are trying to find out here. So linear programming is called a linear optimization. So it is one of the optimization method we have. Uh, So we try to maximize the profit or the minimize the cost or lower the cost. This is the mathematical model whose requirements are represented by the linear relationship. So in this problem, if you see, they give you some information and they ask you to find out something in that information, like if we see one problem and then it will be clear to you, so how to choose the decision variables. So whatever generally your decision variables are, they try to calculate, they ask you in the problem to calculate those variables. Okay. So you have to formulate the objective function, use the information given in the problem to formulate the constraints. Constraints are the limitations. Okay. So basically limitations or the information related to the problem. So the constraints, you're writing the number of constraints, and you're using the constraint to minimize or maximize the objective function. So linear programming problem deals with the optimization problem of the 2 linear variables. The function formed using those 2 linear variables is called the objective function. So whatever the function we have, which has been formed by the two variables. Decision variables is the objective function. So we can see so many examples of this in day-to-day life, like many applications in the mathematics also involve linear equation inequalities. Hence, those applications-based problems which seek to maximize and minimize are the optimization problems. So if you once you go through few of the problems, you will come to know where we use this actually. The linear programming, and the special case we are learning here is the two variables linear programming problem, which we are solving using the graphical method. So you have the objective function, which you have to maximize or minimize. We denote the objective function by the capital Z or Z, you can say. So we write the objective function like this. This is the objective function we have, and we have to maximize or minimize it with using the given information, which we write in terms of the constraint. So this is one of the problems. So we'll go through the problem first, and then I will explain you the different terminologies we use in the linear programming problem. So while explaining the terminologies, I'm using the same example. Okay, so we go through the example first, and then okay, so a company produces two types of TVs. One is black and white, and the second one is color. So what the company is doing, company is producing two types of TV. The first one is black and white TV, and the second one is the color TV. The company has the resources to make at most 200 sets a week. So the first information is the company can produce maximum 200 sets in a week. Creating a black and white set cost rupees 2,700 and 3,600 to create a colored set. So the black and white TV cost is 2,700 and the color TV cost is 3,600. The business should spend no more than rupees 6,48,000 a week producing TV sets. So the maximum cost available for this production per week is 6,48,000. If it benefits from rupees 525 per set of the black and white and 675 per set of the colored, how many sets of black and white and colored sets should be produced in order to get maximum profit? So formulate this using LPP. Okay, so what is given here? The company is producing two sets, and what is asked? How many sets of black and white? How many sets of black and white and color sets should it produce? So you by whatever the asked in question gives you the idea about what are your decision variables here. So we have the two variables x. X is be the number of black and white TVs. So this is wrong here. Just forget this. X be the number of black and white TVs and Y be the number of colored TVs. Okay. So X be the number of black and white TVs and Y be the number of colored TVs. So once you have the decision variables, you are trying to find out the objective function. So objective function, what is the objective function? You have to maximize the profit. Okay. So the profit per unit is given. Okay, if the benefits from 525 per set of black and white means this is the profit for the per set of the black and white TV, and 675 is the profit for the per set of the colored TV, right? So you can write the objective function like Z is equal to 525x plus 675y. This you have to maximize. This function you have to maximize. This is your objective function, which you have to maximize. Subject to the constraints. Now we have the different constraints here. Constraints are you can say are formulated using the information given in the problem. So the first one is your x and y always greater than 0. So why this is the thing? Because what is x? X is be the number of the black and white TVs the company produces. Y is the number of color TVs the company is producing. Okay, so this number cannot be negative. Either it is 0 or greater than 0. So whatever your decision variables, they don't take the values less than 0. They don't take the negative values. Okay, so we call this as a positive constraint. This is always there in any linear programming problem. Okay, so this constraint you will observe in any linear programming problem. X is greater than 0 and y is greater than 0. So what is the next constraint we have to form? So the next one is, what is the information, other information given? The company has resources to make at most 200 sets. So at most 200 sets a week. So x plus y must be less than equal to 200, quantity constraint, right? So they cannot produce more than 200. So number of units of x, x is the number of units of black and white TVs, and y is the number of units of color TVs. So the total number cannot exceed 200. What is the more information given? Creating the black and white TV cost. The cost constraint is given. So the cost for the creation of the black and white TV is 2,700 and color TV is 3,600. So the cost of production is given and the total cost available per week for the production is given. So this is your cost constraint. So once we have the constraint, how we are going to solve this? So we use this constraint to solve the problem to optimize the objective function. So what we are doing, we are plotting this constraint on the graph, Cartesian coordinate system. Like we have x-axis, we have y-axis. We consider them as a straight line, like x plus y is equal to 200. We try to plot it and then decide what actually the constraint is. If the constraint is less than sign is there, so you will show the pointers towards the origin. If the greater than sign is there, that time you can show the pointers outside the towards the empty space, opposite to the origin. Okay, so by this way we try to find out the common area formed by all the constraints, and then we try to check the optimum points at this corner points. We try to check the optimality at this corner points. So, and then once we have these points, we check the optimality. We try to maximize or minimize the objective function. In this case, we are trying to maximize the objective function. So for the 0.00, the value is 0. So here the maximum value is this. It means we can suggest that the company must produce 80 black and white TVs and 120 colored TVs. So let's see all. Now I have just given you the how to solve the problem that I told you now, right? So now what we will do is, now I have some common terminologies generally we used in linear programming. So I'm reading one by one, like decision variables. So decision variables are x and y are the decision variables in the objective function. So in this case, the objective function is 225x 675y. So x and y are the decision variables. So how to find out the x and y? Generally, in a problem, the things which they asked you to find out, how many sets of black and white and color TVs. So those are your decision variables. So the first thing in your LPP is you have to decide what are your different decision variables. Then the next terminology is non-negative constraints. So your x and y always takes the value greater than 0. You cannot produce the things with the negative quantity. You either can produce anything, or you can say that you are not producing, so the value is 0. So this constraint cannot be negative. Okay, then the constraint is a linear inequalities or equations on the variables of the linear programming problem are called constraints. So these are the inequalities or equations we are forming using the given information in the problem, and these are the constraints to the problem. So we use the constraint to minimize or maximize the objective function. Then optimization problem. So this is a problem which seeks to minimize or maximize a linear function subject to the certain constraint as found by the set of linear inequalities. So LPP are special type of optimization problems. Optimization problems means any problem in which you try to find out the minimum or maximum value as per the requirement in the problem. Then we have the feasible region. So what is the feasible region? So once we have the constraint, we try to plot them graphically and the common area to all the constraints. So in this case, you can see the common area to this constraint is the region R. So this is the common area to this constraint because this constraint also has. One second. So the common region here is the feasible region. Okay, so how we decide which region is the feasible region? So if you see here, if this constraint x plus y is less than equal to 200, right? So your values of x and y are, for this particular x plus y is equal to 200. So how you plot this line on the graph? When x is equal to 0, that time y is equal to 200. So your first point is 0, 200. Okay. So when y is equal to 0, your x is 200, right? So your point is 200, 0. So you find these 2 points, then you join the points by straight line and you decide. Now, what is your constraint? X plus y is less than equal to 200. So x and y always taking the values from this side, right? So you're showing it by these arrows towards the origin. Okay. So you're showing it by arrows towards the origin. So your second line, if you see, the second line is 2700 x plus 3600 y is less than equal to 6,48,000. So if you want to plot this line on the graph, so you will say x is equal to 0. So what is the value of y? When y is equal to 0, what is the value of x? So you will get the 2 points. The 2 points are 0, 180 and 240, 0. So you are joining them by straight line. So again, the total cost is 6,48,000. So it is the maximum, and your x and y always taking the values less than that. So again, you're showing the pointers towards the origin. Okay, so the common, also you have the non-negative constraints like x and y always takes the positive value. So this becomes your feasible region, the common region. Okay. So once you have the feasible region, the region other than feasible region is invisible region. So yeah, invisible region is the region other than the visible region. So all the other region on the graph is invisible region. Just the region, this region R, the common region is your visible region. Okay, so only this region is your visible region. All other region is invisible region here. So then we have the visible solution. The points within and on the boundary of the visible region denote feasible solution of the constraint. So if you want to find out the feasible solution, any point which is in between this region, so let's say this point or which is on the boundary of this feasible region, all these are the feasible solutions to this LPP. Okay, so then we have the invisible solution. Any point in the invisible region is invisible solution. Then how to find out the optimum solution? If the point is the visible region gives the maximum or minimum value of the objective function, it is called the optimum solution. So it is confirmed that the visible solution points, one of the point from the feasible solutions will give you the optimum solution, where the objective function is maximum or minimum. Okay, so we are why we are checking at the just endpoints? If all possible points, there is a possibility that we can check at any point. Feasible solution is any point in that feasible region, right? So we can check basically at any point, but we are not checking at any point. Why we are checking at just the corner points? Because we have two theorems. Okay, let R be the feasible region for an LPP and the objective function, the optimum value of Z must occur at the corner point of the feasible region. So the theorem tells us that your optimum value will always comes at the corner point of the feasible region. And the second theorem is telling us that the R is the feasible region if R is bounded, then the objective function Z has both maximum and minimum value in the region R. So maximum value for that for particular function and minimum value both are exist in that feasible region at the corner points. Okay, so according to our requirement, whether we want to maximize or minimize the objective function, we are choosing the optimum value. So if the objective function is related to the profit, you are interested in maximizing it. If the objective function is related to the cost, you are interested in minimizing it. So it's your decision what you want to maximize it or minimize it. Both the maximum value and minimum value are at the corner points only. If R is unbounded, then the minimum and maximum value of the objective function may not exist, and if exists, it comes at the corner point. So here our visible region is the bounded region, but sometimes it is possible that you have the graph like this. So you have x-axis, y-axis, and you can have the graph like this where your pointers are like this, and this is the common region you have. So if this is the common region, that time this is unbounded region. So you are checking at these points. Okay, corner points. So this is example we have. So this is the explanation to the linear programming problem. I have one example in front of me. We'll solve this example and then we'll stop here. Okay. So this is just the introduction to the LPP. We try to solve this example. A school is preparing a trip of 400 students. A company who is providing the transportation has 10 buses of 50 seats each and 8 buses of 40 seats, but only have 9 drivers available. The rental cost for large bus is 800 and 600 for the small bus. Calculate how many buses of each type should be used for the trip for the least possible cost. So what is asked here? calculate how many buses of each type should be used, right? So how many buses of each type? So what are your decision variables here? Can you tell me what are your decision variables here? Let's say XB, number of large buses, YB, the number of small buses. Because you have to calculate how many buses of each type should be used for the trip for the least possible cost. So your objective function you want to minimize. The cost function is there. So you're interested in minimizing the cost, right? So the objective function, below this, we will write the objective function. So what is the objective function? We denote it by Z, right? So what is the objective function? What is the cost per bus? 800 for large bus, right? 800x plus 600y. So this is the objective function you have, which you want to minimize. Okay. So write down the constraints now. Subject to constraints. So your first constraint is your x and y are always greater than equal to 0, right? This is your first constraint. So what is your second constraint? The second constraint is read the problem. The school is preparing a trip of 400 students. The company who is providing transportation has 10 buses of 50 capacity each and 8 buses of 40 seats. So what will be your second constraint? 50 capacity for large buses, right? 50 is the capacity for large buses. 40 is the capacity for the small buses, and total number of students are 400. So this is your second constraint. The third constraint is only 9 drivers available. So 9 drivers available means they can have maximum 9 buses, right? They cannot have 10 buses. So x plus y is less than equal to 9. So now you have the 3 constraints. So you're using the 3 constraints to solve the problem to minimize the objective function. So now we'll try to plot these all 3 constraints graphically and try to find out the feasible region. Okay. So the first constraint, x, y greater than equal to 0, right? So this is your y-axis, this is your x-axis. So you are always saying that you are considering positive part of this, because this is your first constraint, right? So what is the second constraint? X of 50x plus 40y is cannot exceed 400, right? Less than equal to 400. The total capacity, the total number of students, maximum number of students available, 400. So 50x plus 40y is less than equal to 400. So when x is equal to 0, what is the y? Y is equal to 10, right? When x is equal to 0, y is equal to 10. And when y is equal to 0, what is the value of x? So your first point is 0, 10. When y is equal to 0, then x is equal to 400 divided by 50, right? That is 8. So your point is 8, 0 and 0, 10. So first we'll write down the numbers here. 1, So we select the scale accordingly. Here we have to plot the points like 0, 10, 8, 0. That's why I'm taking scale like this. So first you have to see which points you are plotting, and accordingly you can select the scale. So 0, 10. 0 and 10 is your first point. 8, 0 is your second point. You're drawing the straight line passing through the 2 points. Okay. So less than means they are taking this side value. So by this, for this equation, this line is 50x plus 40y less than equal to 400. What is the second constraint? X plus third constraint, sorry, y less than equal to 9. Only 9 maximum drivers available. So you have 2.09 and 90, right? So your points are 0, 9 and 90. So you are drawing the straight line passing through the points, and you have to find out this point. Okay, so when you do the calculations, you have to find out this point. How to find out this point? You know the equation of both the lines. You can solve them simultaneously and easily find out the answer. Okay, so or otherwise, if you have used the graph paper, that time you can easily find out. But no need to use a graph paper. You can easily do the calculations and find out the answer. So this equation is for x plus y is less than equal to 9. So when you solve the two equations simultaneously, how to solve them? Like, let me erase this. So you have two lines. 50x plus 40y is equal to 400. And the second equation is x plus y is equal to 9. So you have to solve them simultaneously. So what you will do, you can either multiply the second equation by, let's say, let multiply equation. This is your second equation and this is your first equation, let's say 2 by 40, let's say. So if you are multiplying the equation by 40, 50x plus 40y is equal to 400. So 40x plus 40y is equal to multiplying by 400, 9 by 40. So then subtract the second equation from the first equation. So your answer will be 10x is equal to 40, right? So x is equal to 4. Once you know the x, you can easily find out the value of y, because x plus y is equal to 9. So y is 5. So your points are 4 and 5. So what this point is, now your feasible region is this region, right? The common region. So first point is 0, 0. This point is 8, 0. This point is 4, 5. And the last point is 0, 9, right? So you are checking the solution at these points. Let's check the solution at these points. 0, 0, 8, 0. The points are 0, 0, 8, 0, 4, 5, and the last point is 9, 0, right? 0, 9. Sorry. 0, 9, because it's on y-axis. So what is the objective function here? 800x plus 600y. This is the objective function which you have to minimize. So when 0, 0, the z is 0. For this 8, 0. So what is the value here? So z is 6400. So for this, the value is z is 3200 plus 3000, that is 6200. And for this last point, what is the value of z? Z is like 5400. So the z or your objective function is minimum at the last point 09. So we will give the suggestion that using the given information, we observe that the school must go with the 9 small buses. The school must go with the 9 small buses. So here we are done with this unit linear programming problem. I'm sharing a link with you. Kindly go to the link and share your feedback. If you have any questions in this unit, you can ask me now.